So just looking at the log laws involving, we're looking at differentiating log functions involving log laws. Here's our first log law. Log to the base a of x times y is log to the base a of x plus log to the base a of y. Log to the base a of x divided by y is log to the base a of x take away, minus log to the base a of y. And the last one is b of a to the power of x is, how do we do this one? No, log to the base b of a is. Remember we do this as log to the base, remember we used e if we wanted, a over log to the base e of b, or you could write it as ln a on ln b, or you could even do log to the base 10 of a over log to the base 10 of b. Remember all those? So you can take, so really a general form would be log to the base x of a over log to the base x of b, if you wanted. But we would use log to the base e over log to the base e, or ln, or log to the base 10. Why do I choose e or 10? Why? Because, no, they're the same, but because they're on your calc. We choose those because if we wanted to evaluate it, it's on our calculator. You can do log. When you press log on your calc, it's log to the base 10. So this enables you to calculate the values on your calculator. Because you've only got the log, log, and the ln button on your calc. But if this is just a general form, log to the base x of a. So basically, the a is the big one, and on the denominator is the smaller one. That's what you've got to remember. And you're able to take the same base. Now, these two are identical. Log to the base e is ln. All right? Differentiate the following. Log to the base e of x squared plus 1 on x. We can't do that. If you look at your formula, it's log to the base e of the function of x. You can't go applying any funny rules. You have to use your log law to break it up. So which log law will I be using here? 1, 2, or 3? The second one. Okay, so what is it? So using the log law, I get log to the base e of what? Of the numerator minus log to the base e of whatever the denominator is. So log to the base e of x squared plus 1 minus log to the base e of x. Now lucky they're log to the base e. What is the rule? The rule from your formula sheet is if y equals, I think it says ln on your formula sheet. It says this on your formula sheet, ln function of x. Anyone know the rule? Y dash is what? 1 over the function of x times the derivative, or this is on your formula sheet. If y is ln function of x, y dash is f dashed x on fx. So off you go. Come on. That's the same as this. ln is log to the base e. So how do you do the derivative? Well, you can do 1 over the function times the derivative, or you do the derivative over the function. It's the same thing. So we want to do the derivative over the function. So we get the derivative is 2x over x squared plus 1 minus, what do you get when you differentiate ln x? If y is ln x, do you remember the derivative? Y dashed is 1 on x. Because it's the derivative of x is 1 over the x. Okay, and that's your derivative. I don't think you'd need to make a common denominator. It's fine. Okay? All right, let's look at another one. Number 2. This one, if function of x equals log to the base e of e to the x times x squared plus 3. Okay, which rule? I know it looks a bit horrible. Which log law? It's the log of something times something else. So it's the first one. The times goes with the plus, and the divide goes with the minus. So you would break it up. Oh, so sorry, girls. What have I done that's really, really bad here in the first one? I should be writing y equals and dy dx equals. All right, so please, y equals, that is still the same. It's still the original function, dy dx equals. Okay, so I've got function of x equals that. So function of x equals log to the base e of e to the x plus log to the base e of x squared plus 3. All right, now, what's log to the base e of e to the power of x? What do I do with that x? I bring it to the front, x. So I'm actually not even starting yet. This is still my function. What does that, log to the base e of e goes? It's actually one. So what have you actually got? But the rule is, so I didn't write this rule at the top. I did the change of base, but I didn't write this rule at the top. So I better write this rule at the top. Okay? Can I do that? Come back up. One more rule. I was doing it. Log to the base a of b to the x. That'll do. It's the power 1. The x comes to the front. Log to the base a of b. Okay, so if you've got a power, log to the base a of something to a power, the power comes to the front. We normally put n there, don't we, in the rule? It doesn't matter. Whatever it is, it comes to the front. The power comes to the front. Okay? Okay, so I have not even started differentiating yet. I haven't started. So what's this? Notice I haven't started. I don't have to write this out all these times. I only need it once. But when I do the derivative, I then introduce the f dashed x. What's this? X plus, now I can differentiate it. But let's say you didn't pick it up. We could still differentiate it the other way if we want. And we will in a minute in case. So let's say you didn't see that to bring the x to the front or to know that that is just x. All right. Remember that one is actually on your formula sheet. Looking at your formula sheet, log to the base a of a to the power of x is just x. Okay, because the x comes to the front. They do have the change of base on the formula sheet, but with slightly different pronumerals to what I used. All right. Okay, so we keep going. Now we can differentiate. F dashed x is, what do you get? Differentiate x and you get 1 plus, here log to the base e of function of x is f dashed x on fx. Now, let's say you didn't realize that log to the base e of e to the x was just x and you decided you're going to apply the rule. How would you do it? Let's say you didn't realize that that was just x. So back up here. Let's say you didn't realize to bring the x to the front and know that that's just x and you differentiate it and get 1. You would have to use ln function of x rule. All right. So if we did do it like that, let's say we didn't know the rule. How would you do it? Long method. So isn't it the derivative of your function? Because isn't that f dashed x on fx? Isn't that the rule? If y equals log to the base e of a function, then the derivative is the f dashed x on fx. What's the derivative of e to the x? Over the function, e to the x, which is 1. So it would have worked as well. Yes? We could have brought the x to the front, know that that's x differentiated to get 1, or we could have just used the normal rule for differentiating ln function of x.